In this exercise, we're looking at position vectors in terms of time. So the first thing I want to do is just talk about the difference between the information Cartesian equations give you compared with parametric equations. So if I gave you a Cartesian equation, x squared plus y squared equals 1, which is the unit circle, the only thing you can really do with that is draw your circle of radius 1. It gives us no more information than the particle is moving on a path of radius 1 around the origin. But if we were to do this as a parametric equation where we define x is equal to the cosine of t and y is equal to the sine of t, we know cos squared t plus sine squared t equals 1. So replacing cos t with x, I get x squared, plus replacing y equals sine t with y, I get y squared equals 1. You can see they're the same thing. So the graphs look the same. Now we can begin to find more information. For instance, we know the particle has to start when time is 0. When time is 0, we know x is equal to the cosine of 0, which is 1. Y equals the sine of 0, which is 0. So I know my particle is going to start at the point 1, 0. I've just marked that in on the graph I've got on the left-hand side. So we can write down the parametric equation by using our position vector formula. Position vector equals the x ordinate times the I unit vector plus the y ordinate times the j unit vector. As said before, x is equal to cos t, y is equal to sine t, so I've then replaced them. So I've now got the equation x squared plus y squared equals 1 in Cartesian form. I have got it in parametric form, and I actually know the position my particle starts. So I can begin to investigate this a little bit more. I can work out which direction my particle is moving. You can do this in a number of ways. The easiest way would be to substitute in a value. The idea would be to make something easy for you. For instance, if I said time was equal to pi over 2, then x would equal the cosine of pi over 2. The cosine of pi over 2 is 0. Y would equal the sine of pi on 2. The sine of pi on 2 is 1. So I have the point 0, 1. 0, 1, I've just marked in with a little x on the axis. So it's telling me that my particle is moving in the anti-clockwise direction. Also, I'm moving around the circle, and it's moving around the circle with a period of 2 pi. So there's a lot more information that we can get from the parametric form than the Cartesian form by itself gives us.